And so we begin with unit number 3 in math. Factors and products, as you can see. You can flip over to page 135, that's where I'll begin, but just a brief introduction. Factors and products. Factors of a number are, of course, the numbers that multiply to make up the number. So 16 has 1 and 16, 4 and 4, 8 and 2, right? 16 times 1, 4 times 4, 8 times 2. Those are the factors. So 1, 4, 2, 8, and 16 are the factors of 16. 25 is 1 times 25 and 5 times 5. So the factors of 25 are 1, 5, and 25. Factors of 36 would be 1 and 36, 2 and 18, 3 and 12, 4 and 9. I think that's all of them. So those are the factors of a number. Product is, of course, what you get when you multiply a number. 8 times 8 is 64, therefore 64 would be the product of 8 times 8. So that's the basis of this unit. Factors and products. They are key mathematical operations. They are the base of so much of what we do with numbers, whether that's so. Let's flip over to page 135, and I'll begin by working through this example here. Write the prime factorization of 3,300. Let's give you a heading. Unit 3, factors and products. There will be 2 lessons from this unit this week. So I want to do the prime factorization of 3,300. We can begin with 33 times 100. It's a good place to start, right? Because it's easy. Anytime you can be dealing with 100 or a 10, or you should do so. Makes your job easier. 33 times 100 is 3,300. Because 33 times 1, then it's 33, add the zeros. So we continue our breakdown. What are 2 numbers that multiply to make 33? Well, they would be 3 and 11. Well, 3 and 11 are prime numbers. That means we're finished with this side. You can't break them down any further, except multiplying them by 1, which doesn't change anything. 10, 2 options. We could do 10 and 10, or we could do 4 and 25. I'll go with 10 and 10. And for the 2 tens, we get 5 and 2. So, the prime factorization then of 3,300 is 2 2s, a 3, 2 5s, and an 11. Simple as that. Those are the prime. When you break 3,300 down, the numbers that you're left with, when you've simplified it down as far as you can. 3 and 11 can't be simplified any further. 5 and 2 can't be simplified any further. You had 2 sets of 5s and 2s with your 10s. So there you have it. You could have also done the way they did it in the book there, as you might see. We could have used 4 and 25 here. we will still gotten 2, 2, and 5, 5. It's just, tens are just a different way of doing it. Doesn't matter actually how you do it. So that's prime factorization. Let's have a look at some work on the greatest common factor. I'm looking at page 136 now, if you want to flip over there. And we're going to look at the greatest common factor of 138 and 198. 138 and 198. So, factors, the numbers that multiply to make up different numbers. We want to know what those are. And you can do that easily by dividing. So you take 138 and 198. They're both even numbers, so you can immediately see that they'll be divisible by 2. And I would just use a calculator here. Divide by 2 is 69, and 198 divide by 2 is 99. And so I'll continue my way down. Let's see if they're divisible by 3. 4 and 8, that's 12, and this is 10 and is 18. Those are both numbers. If you add up the digits and the number is divisible by 3, then that means it's divisible by 3. So we can do that. $138 divided by 3 is 46. And the other one is 66. Now if a number is divisible by 2 and 3, that means it's also divisible by 6. That means both of these are divisible by 6. They're not going to be divisible by 5 because they have to end in 5 or 0 for that to work. And they won't be divisible by 4 either. So let's move to 6. 138. Divide by 6 gives us a 23. Oops, I didn't write 198 here, but I think I still put the correct answer, didn't I? Yeah, I did. 198 divided by 3 is 66, and then 198 divided by 6 is 33. Okay, 7. Let me check. Nope, 7 doesn't go. 198 doesn't go into 7 either. Let's try 8. 138 divide by 8. Nope, that doesn't go. 198 divide by 8. That doesn't go either. Let's try 9 then. 138 divide by 9. Nope, that doesn't go. 198 divide by 9. That one goes, so we'll record it. 198 divided by 9 equals 22. And let's keep going. None of them will work with 10 because you have to end in 0 to be divisible by 10. Let's try 11. Oh, actually, with 138 we were finished at 6 because once you get a prime number, then you're finished. But we can try 198 for 11. Divide by 11 is 18. So that's all the factors we have. So what is the greatest common factor that the two numbers had, the one that they both had. They both have a 2 and a 3, and they both have a 6. So the greatest common factor is 6. But that's essentially how you do it. Use your calculator and keep checking until you've got all the factors. And here, once your answer was a prime number, then you knew you couldn't divide any further. And you could have divided more numbers by 198. In fact, I did 2 more than I really needed to. But you've already identified the 6. And even if you get more factors here, 138 isn't going to have any more factors. Right? I could keep going here, and eventually I'll get to an answer that's a prime number, and I'll be finished. But I don't need to. I don't need to go any further than 6, actually. 6 is the factor that they have in common. You're not going to find any more factors that it has in common with 138 because 138 is finished. See? So that's one of the tricks, is don't do any more than you have to. Now I'll look at an example over on page 137, and that's the least common multiple of 18, 20, and 30. So your multiples, right, is multiples of 5, let's say. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. Those are your multiples. So essentially, 18 is your first one for 18. And 18 times 2 is 36. I'm just going to do these mentally. 18 times 3, so 30. Just keep on adding 18. 46, 54, 64, 72, 90, 108, 108, 118, 126, 136, 140, 144. Let's leave that there, and let's do a bunch of multiples of 20 and see where that gets us. And 20 is easy, of course. 40, 60, 80, 100, 120, 140, 160, 180, 200. So nothing in common yet. Let's extend this one a bit. 144 at 18. Starting to get lazy here, so I'll add the 18. That's 162. And 162 add 18 is 180. So we have 2 in common here. Now let's see. Is the 30 going to have a 180 as a multiple? 30, 60, 90. Just counting my 30s here. 120, 150, 180. So the lowest common multiple is 180. Once you have it for all 3 numbers, you stop. They're asking what's the least common multiple of 18, 20, and 30. The hard one is the 18. The other 2 are easy, right? It's counting by 20s, counting by 30s. Anybody can do that. It's easy enough. Okay? So that's least common multiple. That's 180. Next concept we'll find on page 138. I'll need a fresh page here. But first, let's read the question. This is example 4, page 138. What is the side length of the smallest square that could be tiled with rectangles that measure 16 centimeters by 40 centimeters? Assume the rectangles cannot be cut. Sketch the square and the rectangles. So, let's sketch a square here. Now think about this. Here we have a 40 and a 16. Here you could have another 40 by 16. Of course, this is a rough approximation. This is just to give you a visual of the problem. A whole bunch of 40 by 16 rectangles placed into a square. So, what's the side length of the smallest square that could be tiled with rectangles? So, 40 by 16. So if you had this side would be 80, and then you could go 16, that's 30, it's for day 16, right? 16, 32, that's 48, and 48 and 16 is 64. 64 at 16 is 74. That's 74. 80. So the smallest square you could make with these kinds of tiles would be an 80 by 80 square. Because this is 80 and this is 80. It's 40 by 16 rectangles would be 80 by 80. Smallest square you could make with 40 by 16 rectangles would be 80 by 80. Simple problem, simple solution. Let's look at your homework now for this lesson. It'll be on, I'll do everything on page 140. Page 140, number 3, 4, 8, and 16. And what I thought I'd do is I'll do the first question of each set. Okay? Question number 1. List the first 6 multiples of each number. So again, I'm working from page 140. This is 140, number 3A. And the first 6 multiples of 6, 6, 12, 18, 24, 30, 36. You're all going, yeah, you did the easiest one. Well, tough. 4A. We want the prime factors of 40. That's what it's asking you to do. So we can begin with 10 and 4. Could have gone with 5 and 8, doesn't matter. The 10 will have a 5 and a 2, and the 4 will have a couple of 2's. That's as far down as I can go. The prime factorization of 40 is 2, 2, 2, and 5. In case you haven't figured it out, when you're doing prime factorization, you wind up with a whole lot of 2's. 8. Determine the greatest common factor of each pair of numbers. 46 and 84. These are both going to be divisible by 2. 46 divided by 2 is 23. And 84 divided by 2 is 42. If I add up the digits, this one is not divisible by 3, but this one is. 8 add 4 is 12. 84 divided by 3. I'm going to use my calculator for that. I'm feeling a little lazy. 28. Pretty sure 84 goes into 4 as well, but I'll check that. 21. See, 40 divided by 2, that's already a prime number. So, oh, I should have caught on to this immediately. 46 divided by 2 is 23. 23 is a prime number. That means you will not find any more numbers that are divisible by, that can divide 46. So your prime, the greatest common factor, GCF, equals 2 for 46 and 84. 84 would have more numbers, but you can stop. You know that 46 won't have any more. Once you divide something and you get a prime number, you know you're finished. Like 84 will go into 6, for instance. 84 divided by 6 is 14. That means you know you can do another one. I wonder if that's 7. Yes. 84 divided by 7 is 12. Now you're definitely done because 7 and 12 are both prime numbers. So there you go. But the greatest common factor that they had was the 2, because their 23 only has a couple of factors, well, other than having 1 in itself, of course, which we don't really count. So the greatest common factor here was the 2. Number 16, adding or dividing fractions. I'll do the first 2. I will do D and E, and you can do the rest. You can do the other 6. So D, 9/10, add 5/14, add 4/21. So you gotta find their common multiple here. You gotta find their lowest common multiple. Okay? So let's do a whole bunch with the 10 first of all, because that one's easy. Let's go up to 100 with a 10. 28. 14 at 14 is 28. 28 at 14, 42. 42, 52, 56, 70, 84. The 21's probably not going to have 70. 84, 94, 98, 98, 112. Hmm, 112, 122, 126, and 140. Well, let's stop there for now. Let's move the 100 up to 140 as well. 120, 130, 140, or the 10 rather. Now, let's go with the 21. 21. Double 21 is 42. 42 add 21. 52, 62, 63, 73, 83, 84, 94, 104, 105, 115, 125, 126, 136, 146, 147. Oh wow, this is going to be a while yet. 147, 21 is 67, 168, 178, 188, 189. Oh my goodness sakes. This is crazy. Oh, no sense stopping now. 210. Maybe this will be the one. Maybe this will be the one. 210. Well, 210 will definitely be a multiple of 10. If I keep counting, we'll get there. Let's see if we get 210 out of 14 as well. 140. Add 14. Add 14. Add 14. Add 14. 14. Yep. 210 is the magical number that we're looking for. Just didn't bother doing all the counting. So, let's do this question. 9/10 into 210. 5/14 into 210. 4/21 into 210. So 10 times 1 is 210. 10 times 21, right? Yeah? Let's double check that. Yeah. So then we go with 21 times 9. So this is times 9. No, sorry. Times 21. Times 21. And 21 times 9 is 189. 14 into what is 210? Let's find out. 210 divided by 14, 15. Times 15 times 15. 15 times 5 is 75. And 21 times 10 will be 210 times 10 is 40. Oh, the hard part's done now. I just have to add these numbers up. 189 and 2/10. 75 and 2/10 and 40 and 2/10. 189 at 75 at 40. 304 over 210. Obviously I can pull a whole number out of here. So this is going to be 1. What's 304 take away 2/10? 94. 1 and 94 over 2/10. I can divide here. Wondering what they'll both, well, 2 would work, but oh, 94, it won't go any further than 2. So 94 divided by 2 is 47, and 210 divided by 2 is going to be 105. 1 and 47 over 105. Okay, you're probably all going crazy right now. Just ask you for number 16 to do A, B, C. For number 16, A, B, C. And let's go back to the other sheet where I recorded your homework. Now, where was that? A, B, C. Those are not as long, I promise. They're not, because there's only 2 numbers versus doing 3. Yeah, I mean, it took, what, 10 minutes to do this question? Anyways. That is our first lesson, and again your homework on page 140, 3, 4, and 8, and 16, A, B, and C.